Okay, so we are about to start differential equation. Okay, so before doing differential equation, let us understand what is differentiation. Like, we need to recap what is differentiation. Unless we start with differentiation, we cannot get into differential equation. Okay. So, what do you mean by derivative? Okay, so there is you have derivation and you have integration, two things in calculus. So, what is derivative? What is derivative? So, the rate of change of a quantity y with respect to x is called derivative. Okay, so dy by dx. Okay, so if y is a function of x, if y is a function of x, dy by dx is called derivative. Okay, sometimes it is called the it is otherwise sometimes called the slope. Okay, so let us say we know the equation of a straight line. Okay, y is equal to mx plus c. Okay, let us say this y m, let us say the slope is 4 and x, and then intercept is, let us say, 2. Okay,
Okay.
so that means y is a function of x. Okay, now I want to find out dy by dx. Okay, so dy by dx is equal to 4 because
Yeah.
derivative of x is equal to
Yeah.
0.
Yeah.
No, sorry,
No,
1.
no, 1.
Derivative of x is equal to 1 and derivative of a constant
Constant
2
is
is equal
0.
to 0. So here that means you got the slope to be 4. Okay, so uh, how does it this equation will look like? Uh, so let us say it is something like this, and let us say your intercept is 2, right? Your y-intercept is 2 and the slope is 4. Okay, in this case means the slope is 4. That's why, so derivative is sometimes otherwise called the slope.
Okay.
Okay, so similarly this is a straight line. You can have a curve or whatever. So you, you can have a curve, and at any point if you draw a tangent, that is the slope of the line at any point.
Yeah.
Because it is a curve, so it is changing directions. Okay, in straight line it is same direction. So it is changing direction means it is changing slope. So here when it is almost perfectly horizontal, this is your slope, and then it, it becomes like this. So at some point the slope becomes almost
Yeah.
90 degree, right?
Yeah.
So when 90 degree means slope is infinite.
Yeah.
Like slope is infinite, it is tan 90.
Yeah.
Okay. Hmm. Okay, that is the slope of the tangent. Okay. Then derivative of some standard functions that you should always remember. Okay. Derivative of some standard functions. Okay. So we know derivative of a constant is equal to 0. Why? Because constant means what? This is my
Yeah.
constant. So,
Slope.
huh. So its slope is 0. Okay, so here what is the equation of this straight line? This is x axis, this is y axis, right? So the equation is, let us say, y is equal to 5. Means throughout the y coordinate is 5.
Constant.
So dy by dx in this case is derivative of 5, which is equal to 0.
0.
So the slope is equal to 0 here.
Yeah.
So derivative of a constant is equal to 0, and then one of the most common formula for derivative is dy dx x to the power n, right? So it is nothing but nx to the power n minus 1. I am not going into the derivation of it, just you have to remember those things. Okay. Then 3 dy dx x square root. Okay, what does it mean? Dy
1 by
dx x to the power minus half, x to the power half, right?
yeah.
So here n becomes half. That
1
means
by 2.
half into x to the power half
Half.
minus 1. So it becomes half x to the power minus half, which is nothing but half 1 by root x, right?
1 by 2 root x.
1 by 2 root x. So this is your one derivative, and then uh, some other derivative formula you need to remember is d by dx of sin x is equal to cos x.
Cos x.
Cos x. And then d by dx of sin x, cos x is equal to minus sin x. Cos x is equal to minus sin x. Nice. So these are some of the derivative formulas you should remember. Then d by dx of tan x is equal to sec square x.
Yeah.
You remember, no?
Yes.
Tan x is equal to sec square x. And d by dx of cot x is equal to minus cos x square x. D by dx of cot x is equal to minus cosec square x. So this is tan x and this is cot x, right?
Yeah.
This is tan x and this is, okay, these are tan x and cot x. Similarly, d by dx of tan and cot, then sec, okay, sec x is equal to sec x into tan x. You have to remember these things, no other go, okay. Then d by dx of cosec x
minus cosecant x. Cosecant x cot x.
minus cosec x into cot x. Into cot x. So you can take a snapshot of it. So d by dx of cosec x is equal to this much. Okay. Okay. So we have done tan x, cot x, sec x, cosec x. Yes. And then d by dx of log x.
1 by
d by df of log x is, okay, d by dx of log x is equal to
1 by x.
1 by x for x greater than 0. It should not be negative, right?
Yeah.
Then d by dx of ex, okay,
Ex.
exponential. Ex, that is the same, you have to remember this, same, okay. Then d by dx of ax, okay, other than e some other base, okay. D by dx of ax is equal to ax into log a.
Log a.
Log
A.
a. Okay. And then another d by dx of log x with base a, okay. So that is with base E.
E.
Okay, that is E. Here it is with base A each. Actually, 1 by x log A. That this you have to remember. Okay. So these are some of the important derivative formulas you have to remember. We don't have time to derive all these. Okay. And, then derivative of sine inverse x, cos
1
inverse
by
x
root.
just
I
one.
know all this. 1 by root of 1 minus
Mhm.
x
1
square.
by root
Cos
of
will be
1.
minus 1 by that. Tan
So d
inverse
by
is 1 by
dx
1
of
plus x square.
sine inverse x is equal to
1 by
1
root
by 1 minus x square square root. Okay. Okay.
cos inverse minus root
Cos
of
inverse, sec inverse, cosec inverse, tan inverse, and cot inverse, all these things are there. So, like say d by dx, tan inverse x,
1 by 1 plus x square.
1 by 1 plus x square. Okay. So, d by dx of cot inverse x
Minus 1 by 1 plus x square.
minus 1 by
1 plus x square.
this is tan cot. Similarly, sec is an important one.
1 by
Mm.
x into root.
d by dx sec inverse x is equal to sec inverse x is equal to 1 by
X into
1 by x.
into root. X square.
This is the formula. And then for cosec there will be
Same
minus
thing
sign.
minus.
Cosec inverse x is equal to 1 by square minus 1
Minus.
minus. Okay. So you can take a snapshot, then we will go to some methods of differentiation. Take a snapshot of this. Different methods of differentiation. Like important, these methods you will be using to do differentiation when it is not that straightforward. So what are the different methods or rules that are applicable in differentiation? Okay. So if y is equal to fx plus gx, right? So if you have two different functions but both are functions of x, okay, if this is the case, then dy by dx is equal to d by dx of fx plus d by dx of gx is equal to f dash x plus g dash x. Right?
Yeah.
And if y is equal to c into fx, y dash is equal to c into f dash x. That's all. Okay. If y is equal to, this is 1, this is 2, this is 3. If y is equal to fx into gx, then what is
Product
dy
rule.
by dx?
F dash of x plus.
Huh?
Product rule you have talked.
Yeah, that is called product rule. So the product rule will be fx
Differentiation of
into,
first into second constant plus
fx into
differentiation
g dash x plus f dash x into
into g.
gx. Right? So this is the product rule. Similarly, there is something called the division rule, right? That is important,
Quotient
very,
rule.
very important. So if y is equal to fx by gx, that implies dy by dx is equal to, that is, yeah.
Quotient
So,
rule.
yeah, gx into f dash x minus fx into g dash x divided by, so the minus sign will come into the numerator, and here this term will be gx
Whole square.
gx whole square. This is very important. It is being used everywhere. So these two, these are very obvious. But this in this multiplication and division, here it is a bit tricky, and you have to remember. Okay, there can be questions on this. And there is something called chain rule. Very important. Chain rule. Okay. The chain rule in differentiation. What is chain rule? Chain rule. The chain rule is, if y is equal to fu, if y is equal to fu and u is a function of x. Okay. If y is a function of u and u is a function of x, then dy by dx is equal to, so dy by dx is equal to, okay, so df by du into du by dx. That is the chain rule. df by du into du by dx. So these are some of the important things we need in differentiation. We need to remember to do any differentiation which are not straightforward. All these rules need to be remembered.
Yeah.
The addition rules, the division, when it is a division, when it is a multiplication, when it is addition, what rule do they follow? Okay. And then there is something called second order derivative. So we have been discussing here a first order derivative, dy by dx. Okay. So if a equation contains
d square x by dx.
d square I by dx square, that is called second order derivative. Okay. And then another important thing is derivation, differentiation of a determinant. Okay. So if so this is 5, 6. Okay, so if you have a determinant, let us say P, Q, R, E, B, W, L. So if I is a determinant P, Q, R, U, V, W, L, M, N. So if this is your determinant, okay, then its derivative is dy by dx is equal to, what is this? That will be dp by dx. Okay. Okay, so it's a addition of 3 terms. Okay. So it's a addition of 3 terms. So it will be dp by dx, dq by dx, dr by dx, okay, then u, v, w and l, m, n, these three remain constant. This is one, okay. Then addition,
first two constant and then
p,
second.
q, r, du by dx, dv by dx and dw by dx. Okay. So this is another, so l, m, n, okay. Okay, so this is the second term. So this is the first term, this is the second term. Okay. So we will have a third term also, same P, Q, R, U, V, W, then dl by dx,
dm by x,
dm by dx and dn by dx. Okay. So this is the one. So addition of 1, 2 and 3. Okay. So this is how, suppose somebody asks you to find out the derivation of a determinant you can do it like
Understood.
this. So now we have covered briefly the various formulas and what is differentiation. So these will be, so there can be so many numericals which can be solved using these principles. Okay. So now with this background on differentiation, we will go into differential equation. Okay. Okay, you can stop that actually. How many?